So now we're going to graph a quadratic inequality. So a quadratic inequality is no longer a function because it is an inequality, okay? But it's graphed in very similar way as a quadratic function. I'm going to start by finding my vertex. Since this is in standard form, I'm going to do negative b over 2a. So that's going to give me a negative 3, which is positive 3, over 2 times 2, which is 4, so 0.75. I'm going to go right to my table. So 0.75 is at the center of my table. Now I'm going to pick two integers smaller than 0.75, 0 and negative 1, and then 1 and 2. It's important that I notice 0.75 is closer to 1 than it is to 0. So what does that mean? That means the values for my y's may not be identical. So I'm going to have to do a little bit more substituting here, which is okay. So I'll start my vertex. So 2 times 0.75 squared minus 3 times 0.75 plus 2. So I'm going to use my calculator for this. 2 times 0.75 squared minus 3 times 0.75 plus 2. I'll get 0.875. We'll round that to 0.88. I'm plugging in 0. 0 squared minus 3 times 0 plus 2. That's just 2. 2 times negative 1 squared minus 3 times negative 1 plus 2. It's 2 plus 3 plus 2. That's 7. 2 times 1 squared minus 3 times 1 plus 2. That's actually going to give me 1. And then 2 times 2 squared minus 3 times 2 plus 2. That's going to give me 8 minus 6 plus 2, which is going to give me 4. So notice that these values don't match. And that's okay in this case, because 0.75, like I said earlier, is closer to 1 than it is to 0. When I go to graph this, I'm going to plot my points. So I'm going to plot a point at negative 1, 7. Barely enough room there. I'm going to plot a point at 0, 2. At 0.75, 0.88, I'm going to estimate where that is. At 1, 1. And at 2, 4. So when I connect them, still makes a U-shape. You notice that I connected them with a dash line. Why would I choose to use a dash line? Because going back to my inequality, this was a greater than sign. So because it was not equal to, I'm not going to use a solid connector. So now I need to determine which direction I'm going to shade. Am I going to shade inside or outside this parabola? Well, since 0, 0 is not on the parabola, I'm going to use that as my test point. Is 0 greater than 2 times 0 squared minus 3 times 0 plus 2? Well, when I simplify that, I get 0 is greater than 2. That is not true. So 0, 0 should not be shaded. So the outside of my parabola should not be shaded, which means I'm going to shade inside my parabola. So all of the points that are shaded would be solutions to this inequality. Let's try that again. This time with an equation that is in vertex form. So I know my vertex is 1, negative 3. So I can make my table. I can put my vertex at the center and choose my other x's and plug them in. So that's going to give me negative 1 minus 3, which is negative 4. Be very careful with these order of operations, especially with that negative out in front. So this is negative 2 squared minus 3, so this is negative 4 minus 3, which gives me negative 7. And then on the other side, I get the same values because in this case, 1 is in between 0 and 2. I'll go ahead and make my graph. It's negative 1, negative 7, 0, negative 4, 1, negative 3, 2, negative 4, 3, negative 7. I'm going to connect them with a solid line in this case. And why solid in this case? Because it's or equal to. I see that at the top of the page. Again, as long as I can, I'm always going to choose 0, 0 as my test point. So, is 0 less than or equal to negative 0 minus 1 squared minus 3? Well, when I simplify that, I get negative 1 minus 3. I get 0 is less than or equal to negative 4. Well, 0 is not less than negative 4. So 0, 0 should not be a solution. So in this case, I'm going to shade, again, inside the parabola. And that's how to graph quadratic inequalities.